Today we are embarking on an AI-assisted development security assessment. The question at the heart of this talk is provocative. Is Claude Code secure by design or just secure by marketing? We'll take a security reviewer's lens to Anthropic's agentic coding assistant. I am Ujjwal, currently working at MoEngage as an application security lead. This episode mirrors a secure software development lifecycle. We'll first explore how Claude generates code, then how it analyzes context, and finally, how it verifies with risk assessments. Before judging Claude Code security, we need to understand what it is. Claude Code is Anthropic's agentic coding assistant built with deep context understanding and a security-first design. Its code capabilities are impressive. It operates directly in your terminal or IDE to perform complex multi-file edits and refactoring autonomously. It analyzes entire code bases to understand dependencies and architecture before making suggestions. And it integrates seamlessly into developer workflows, handling pull request reviews, generating test suites, and assisting with bug triage. On the security front, Claude offers scoped permission-based access to limit what it can touch, guardrails to mitigate prompt injection attacks, and even automated security reviews. Though these scans are currently a research preview and are not a replacement for robust SAST, DAST, IaaS tools. Adoption metrics show a 42.8% adoption rate and 75% developer satisfaction. And early adopters report a 164% productivity boost. But high adoption doesn't automatically translate to comprehensive security. Keep that in mind as we proceed. Claude has evolved rapidly from its 2023 debut to today. Claude 1 and 2 launched with basic safety guidelines. By March 2024, the Claude 3 family, Opus, Sonnet, Haiku, introduced prompt injection mitigations. June 2024 brought the faster and more accurate 3.5 Sonnet, which enhanced system prompts. The May 2025 release of Claude 4 hardened tool isolation and permissions, and Sonnet 4.5 later that year enforced context boundaries. In November 2025, the terminal agent known as Claude Code launched, adding an agent permission system. The most recent February 2026 release, Sonnet 4.6, previews static code scanning. Notice how each generation aligns technical advances with improved security controls. This timeline shows a trajectory toward a safer, more capable assistant, but it's still a work in progress. Now let's have a look at common AI-generated patterns. On the left, we see common mistakes. Broken access control where no ownership check is performed, weak JWT validation that decodes tokens without verifying signatures, classic SQL injection by concatenating user inputs, cross-site scripting vulnerabilities through unsafe HTML insertion, and hard-coded secrets baked directly into code. These patterns are disturbingly common in AI outputs. On the right, we see the secure counterparts, explicit authorization checks and exceptions, proper signature verification with JWT verifying, parameterized queries that separate data from code, safe output encoding via text content, and secrets pulled from environment variables rather than stored inline. The takeaway is sobering. AI often repeats insecure patterns from its training data and fails at business logic flaws like IDORs more often than at syntax-level injections. You must audit and transform AI output, not blindly trust it. Why do developers love Claude? For many, the appeal is speed and productivity. Automated code generation can complete stories 164% faster. Others cite deep context understanding that allows AI to analyze entire code bases. Improved code quality with high retention rates, natural language interfaces that feel like talking to a colleague, and built-in security features. Yet each benefit introduces a risk. Faster code means faster vulnerability injection. A larger context means a wider data exposure surface. High code retention doesn't equal secure validation. Plain English prompts might bypass security controls. And research preview security features are not production grade. Here the donut chart visualizes the tension between benefit and risk. Every slice of productivity comes with a corresponding attack surface. Smart adoption requires balancing both sides. How does Claude Code stack up against its peers? This risk assessment matrix compares Claude Code to GitHub Copilot, Amazon's CodeWhisperer, and the base ChatGPT code. On vulnerability rate, Claude falls into a medium category. Its high context window reduces some logic flaws, whereas GitHub Copilot exhibits high vulnerability rates, around 40% according to the NYU study, and ChatGPT code suffers similar issues. Claude stands out by providing built-in scanning, though still in preview, strong guardrails against prompt injection, and robust data privacy options including zero retention modes. GitHub Copilot requires external security tooling. CodeWhisperer integrates AWS scans but only at the AWS level, and ChatGPT code provides no scanning and low injection protection. The final security scores reflect this. Claude earns an A-, strong security posture with controls, Copilot a B, config dependent, CodeWhisperer a B+, enterprise ready, and ChatGPT Code a C-, high risk. This matrix demonstrates that while Claude leads the pack on built-in security, no tool is perfect. Configuration and context still matter. We're now moving beyond conventional vulnerabilities to new paradigms in application security. Code quality reminds us that AI models trained on public code often reproduce insecure patterns. We need context-aware logic validation and must replace insecure defaults with secure ones. Agent safety focuses on protecting the assistant itself, ending against prompt injection and jailbreaking, preventing misuse of tools like destructive commands, and keeping the agent within its sandbox. Supply chain trust highlights the risk of hallucinated dependencies. AI may suggest non-existent or risky packages. Automated SBOMs and reputation checks are essential. Data governance ensures sensitive information never leaves allowed boundaries. No secrets or PII in prompts, compliance logging, auditability, and the ability to opt out of model training. These 4 quadrants illustrate how the meaning of code security expands when AI writes and reviews code. A reality check on the right drives the point home. Controlled evaluations by Veracode and the Cloud Security Alliance found that 45 to 62% of AI-generated code contains vulnerabilities. And the NYU study reports that 40% of GitHub Copilot outputs still include CWE vulnerabilities. This is a problem we cannot ignore. How does AI integrate into your software development lifecycle? There are 3 primary vectors. Generators like GitHub Copilot, CodeWhisperer, and Claude Code perform boilerplate generation, function completion, and refactoring. Their security concerns revolve around insecure defaults, injection patterns, and hallucinated dependencies. Analyzers such as Sneak Code, SonarQube AI, CodeQL, and Deep Code scan for vulnerabilities, detect logic bugs, and assess code quality, but they struggle with false negatives and context misunderstanding. SDLC gates, for example, Jenkins plugins or GitLab AI Assist, automate PR reviews, policy enforcement, and test generation, yet risk so-called trust loops where AI approves AI. A threat scenario in the slide illustrates this. AI writes a Terraform configuration, AI reviews the same config, then merges it, only to deploy a misconfigured S3 bucket. On the right, we see Claude's positioning. It excels as a generator and makes for a reasonable reviewer, but acts as a limited orchestrator, requiring external CI/CD enforcement and SAST tools. Finally, the integration workflow reminds us of the 6 traditional stages: plan, code, review, test, deploy, monitor, and warns that when the same AI instance both generates and approves code, security controls become circular and ineffective. Here's the key takeaway. Keep humans in the loop and avoid AI approving its own work. But is it secure? This is the pivotal question. On the left, we revisit Claude's native defenses. Permission-based access ensures agents only interact with explicitly authorized repositories and tools. Injection mitigations use guardrails to neutralize prompt injection attempts. And automated scanning reviews generated code for common flaws. In the middle, we trace a technical attack flow. An innocuous user input could harbor a malicious prompt, which poisons the context, leads to backdoor generation, and ultimately causes data exfiltration. On the right, we see sobering evidence from 2025. The CamoLeak vulnerability exploited GitHub Copilot chat to silently exfiltrate code. An AI cyber espionage campaign showed an AI executing 80 to 90% of an attack chain. Industry reports have observed up to a 400% surge in security incidents. Furthermore, research notes over 10,000 new AI-related flaws per month and a 40% vulnerability rate in Copilot outputs. Here's the final verdict. Claude Code can be secure, but only if its native features are combined with robust AppSec controls and mandatory human-in-the-loop reviews. Now let's operationalize. This prioritized implementation roadmap breaks secure adoption into 3 phases. Phase 1, Foundation, weeks 1 to 4, focuses on must-have controls. Implement least privilege permissions, enforce comprehensive logging, and ensure no secrets are embedded in prompts. Phase 2, Integration, weeks 5 to 8, introduces should-have controls. Add sandboxing for agent actions, enable context redaction, run SAST or DAST, mandate unit tests, and start generating SBOMs. Phase 3, Optimization, weeks 9 to 12, deploys advanced controls, restrict AI context windows, verify signatures on dependencies, track provenance, and map AI security practices to OWASP 2025 categories like A01 access and A05 injection. Notice how the roadmap encompasses people and process as well as technology. Human review is a must-have. Separate roles are advanced controls, and ongoing training is assumed. The critical takeaway is highlighted at the bottom. Start with must-have controls before enabling AI coding assistance in production. We end this episode with a risk-based adoption framework. The green zone, safe for production, requires that AI outputs are treated as untrusted input needing validation. You must have enterprise-grade SaaS DaaS tooling, mandatory human reviews of all AI-generated code, separate AI writer and reviewer instances, enforced SBOM and dependency scanning, and a security-trained development team. The yellow zone, or proceed with caution territory, describes small teams without dedicated security review or with limited CI/CD gates who may copy AI suggestions but conduct only basic manual review and have no formal secure coding training. The red zone, high risk and not recommended, covers cases where developers copy-paste AI code directly into production without scanning or review, single-person projects with no oversight, or any scenario handling sensitive data without security controls. The final recommendation underscores that AI coding assistants are tools, not substitutes for security expertise. Your success depends on organizational maturity and robust controls. I hope this journey through Claude Code security was enlightening and thought-provoking. If you found this episode valuable, please like, subscribe, and comment below with your thoughts or questions. Your engagement helps us shape future content and continue exploring the evolving world of AI-powered development. Thank you for watching.